The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so number 12 has to deal with the equations of circles. So we want to write the equation of a circle with a center 4, -2, and it contains the point 0, 1. So remember that in general, the equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. What these are, x and y are any point on the circle, h and k are the coordinates of the center of the circle, and r is the radius. So when you want to write the equation of a circle, though, you want it to be in terms of x and y, and you have h, k, and r are constants, so you could find out any point on the circle. Just like with a line, you always want to have y and x in the equation so that you could solve for any point you want. So let's plug in the information that we have. We don't have the radius, but we know that there is some point 0, 1 on the circle. And we know that the center is 4, -2, so we can plug in all of that information. The x-coordinate of the point that we know is 0. We know that the center is 4, or the x-coordinate of the center. The y of the point we know is 1, and the k, meaning the y-coordinate of the center, is -2, so we're going to have to put +2 there because it's minus k. So you can see by doing this we can solve for r, and then we'll have the whole equation. So -4 squared is 16, 3 squared is 9. So r squared is 16 plus 9, which is 25. Keep in mind, unless it asks you specifically for the radius, you don't need to then figure it. Now in this case it's simple because it's just 5. But you don't need to simplify it any more than that, because in the final form you're just putting what r squared is anyway. So here, our final equation then is x minus 4, remember 4 being the center, plus y plus 2 squared. Again, remember that it's +2 because we had a negative value for our y-coordinate of the center, equals r squared, which is 25. So that's the general form of this circle with that center containing that point. So a lot of people might have seen this information and went straight for, let's find the distance formula from the center to the point to figure out the radius and all that stuff. You actually don't need to do that, because a point that's on the circle has to be a value x, y there anyway. So you could always just plug it in like that to solve for r instead of doing the distance formula, which would eventually actually give you the same format as this anyway. So that lends you then to answer choice C, that matches our general equation.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.